emitter in the graphs, but if you consider per capita carbon dioxide emissions, we are the very least emitter among the other regions compared to other regions. So especially from the waste, so how much carbon dioxide emissions here from landfills, dumps and incineration and compost, especially particularly from landfills, carbon dioxide emissions are very high. So that is my carbon dioxide emissions, because recently United Nations required urgent climate action on the global warming. So that's why COP24 conference of parties 21, so almost 198 countries participated in that so climate change. So climate change and global warming is the very important environmental issue standing in front of researchers. So if you see this figure, MSW generation, municipal solid waste generation, according to the World Bank forecast, so globally currently nearly 2.1 billion metric tons of solid waste generated annually. So which is maybe increased twofolds by 2050. So here, especially if we observe this figure, in 2015, from India, especially 200 to 300 metric tons organic waste is generated. But in the near future, 2050, so almost double, twofold, 300 to 600 metric tons of organic waste will be generated, especially from the landfills. We have so this is the solid waste generation type. So global projection of future waste production from 1965 to 2100 maybe in the future. So however, we observe that organic waste is very high organic waste generating in the currently and in the future. So this is the developments of waste management legislation in India. Sorry. This is the historical changes or developments in the solid waste legislations. So here from 1950, they started with the public health and sanitation. Now, clearly through the Swachh Bharat mission, implementation on 2014 year, and recently 2016, from 2016 year, particularly solid waste management rules implemented. So these are the developments of solid waste management policies in India. So here is the brief municipal solid waste treatment technologies. So one is the landfills, second one incineration, composting, recovery and recycling, the finally pyrolysis. So here in India, incineration, most of the 90% completely landfills, very few percent or maybe 10% is incineration. Composting also 1 or 2%. So still we need implement the incineration technologies, and incineration plants implementation in India is required. So this is the brief incineration technology image. So incineration is an advanced waste treatment technology. So, but with advanced gas emission controls with incineration is very costlier. But even though it's mitigate the greenhouse gas emissions. So this is the currently we have the best treatment technology for solid waste. So I started the characterization studies of municipal solid waste incineration as collected from waste to energy plants presented in Telangana state and Andhra Pradesh. So here is the carbonation. Mineral carbonation, so is one of the largest capacity for the carbon storage, and carbonation can be applied for the industrial alkaline solid waste such as municipal solid waste and coal ash, bauxite residues, red mud, steel making slag, so such etc. So everything, because carbonation or accelerated carbonation is economic. So that's why this is a feasible treatment or method for the treatment of MSWI. So here is the energy plants located in AP and Telangana states. So one is Jindal, both are private companies. So Jindal is in Guntur recently, not recently, few years back, they established and started solid waste treatment. So nearly 1200 tons per day. Ramki Group in Hyderabad, Telangana. So this one, I don't know. So this one, how much capacity? There is no clear data presented in the web. So that's why I didn't mention. So next one, this is the characterization studies. Here is the ash sampling. First, ash sampling. So I collected 2 bottom ash samples from those waste to energy plants. So this is the bottom ash images, samples images from both plants. So first of all, after receiving the samples, first I checked water content, how much water content from those 2 samples. So one is 10% and another sample has a 12% moisture content. After drying, so this is the brief concept of MSWI ash recycling. So after taking municipal, this is a brief total recycling, bottom ash recycling. From this, after taking bottom ash, so went for pre-treatment and sieving. So in the recycling part, so first separation the ferrous material, and then after sieving, non-hazardous waste used for the cement materials or ceramic materials and bricks, etc. So hazardous waste need to be treatment with the carbonation, and after stabilization with the solid waste by the carbonation process, then we can use it for it as a landfill cover materials and permeable blocks. So this is the waste bottom ash pre-treatment process, iron ferrous material separation. So almost 5 to 10% ferrous materials is presented in the both samples. So here I didn't go for hazardous waste. So I went for only solid waste, non-hazardous waste. So after receiving this one, drying and sieving analysis with the different sizes, after that characterization studies of the raw samples, and after applying accelerated carbonation, I checked the sequestration capability of those samples. So this is the yes, sir. Process of solid waste particle separation with the different sizes and with the sieve machines. So here is the brief mechanism of this one. Accelerated, this is my experimental setup, and this is the carbonation mechanism. So which is employed through the 8-step, and this is the main mechanism involved. This one, this is the main composition. Based on the particle size, the content of calcium oxide will increasing. So calcium content in the both below 75 micrograms and fly ash, it's like 34 to 36. The remaining elements of metal oxides also presented here. So these are the XRD analysis of bottom ash samples with the different sizes. So here mainly because I got the samples of solid waste, mainly construction waste, so that's why it contains most of the calcite and sand. So that is a quartz and aluminosilicate mineral, the 3 major minerals presented in these samples. Here is the XRD analysis of before carbonation, the original samples, and after carbonation samples. So here main components of incineration is the calcite and microline and quartz in the original bottom ash, and after carbonation it mostly converted the transferred the calcite phase, completely transferred the very small amounts of remaining minerals are presented. If I go for higher temperatures, maybe it completely reduced and maybe only calcite will be presented. So here the sequestration studies of with the different particle sizes. So the sequestration capabilities also increasing with decreasing with increasing with the particle size decreasing. So here is the 600 micron solid bottom ash. It shows 1.98%. So TG-DTA analysis, TG patterns, TG-DTA patterns, and DTA patterns. So here is the another 75 micron bottom ash particle size. It shows 7.22%. Then the final below 75 micro particle size of a bottom ash, it shows 8.31%. Here I showed all the three particle sizes. So if particle size is decreasing, so sequestration capabilities also capabilities increasing. So my future studies are, I want to, after treatment with the carbonation, I want to apply with this, apply these bottom ash samples for ceramic materials and green cement materials. So these are the very highly because currently we have global warming global warming problem. So especially particularly from landfills, so we have to, every government and from the other countries also trying to reduce mitigate the green GHG emissions and also carbon dioxide. So with this accelerated carbonation is one of the best technology for the mitigate the carbon dioxide and utilize the carbon dioxide, not only just storage is not, sometimes is not feasible and highly expensive, but CCU, carbon dioxide capture and utilization. So mineral carbonation or accelerated carbonation is one of the best technology for the mitigation of GHG emissions and also carbon dioxide emissions. Thank you.
Thank you so much, Triveni.
Yes, yes.
For the very nice presentation and a new outlook for question answers. We would do that at the end. You overshot your time a little, but I think we will have that.
Yes, ma'am.
There. Okay. So then
Yes.
we
Thank you so much, ma'am.
Most welcome.
Madam, please call serial number 9, Professor Marvin Delhaus, because he is present here.
Okay. So Professor Marvel El Hoz, El Kura, Lebanon, from Lebanon, the circular economy of plastic packaging, current practices and environmental impact of the PP mechanical recycling plant in Lebanon. Please share your screen for presentation. Professor Marvel, I think we saw you there, but I don't see you there anymore. So
Professor Marvel, I now request to please make the presentation. Please unmute and open the PPT and share the screen.
I think Professor Marvel is not there anymore in the, at least I don't see him in the room.
But Madam, then Oluwadare Joshua is present here from Nigeria. His presentation.
Yes, please.
Serial number 10.
Yeah. Then Mr. Joshua. Oboy Wood from Nigeria, assessment of current status of waste management in Nigeria, best practices and implementation strategies. If you can present your screen, Mr. Joshua, it would be great to start the presentation. I don't think Joshua is also in the room. He's entered twice, actually. Two devices.
Or maybe we can follow the serial number.
Yeah, I think that might be a simpler way, just to follow the serial number. So
The serial number in the back second is the no presenter. Follow the serial number. Technically, a ballot kind. Baba Sheikh.
mm, Joshua seems to be entered from two devices, but probably he's not able to connect. So how do you say we proceed? Directing?
Yeah. One Professor go.
Yes, please. I would suggest till we wait for the other speakers, maybe we can take the question answers for the two presenters who have already presented. And it might just save our time later. So so there was a question from for the first presenter regarding the clarity on density of the 2.9 kg per cubic meter. So this is a question to Ms. Mokulu. Okay. Ms. Mokulu, are you there in the room? Then are there any questions for Ms. Triveni from IIT Tirupati?
Uh, yes, Vishal,
Yes,
if you,
yes,
I had two questions. One was that it was indicated that two samples got analyzed.
yes,
So
sir, yes, sir. Actually,
is
I
there,
did many,
yeah,
actually, I did many samples, but some of them is not yet received, sir, because I need to send the samples to Chennai IIT for a TGDT analysis. From them, I
yeah,
received few samples.
the question was that if more samples got analyzed, do you see that there will be any change or, yeah.
No, sir. No, sir. Because if you did many samples analysis, the particle size is very important. So lesser size has more capability of sequestration. So that's why I choose only below 75 micrometer particle size and 75 microparticle size. The main reason of this, that one, sir, because the lesser the particle size has more sequestration capability. So even fly ash has also very maybe less than 75 or below than 50 microns. So that's why, but I am unable to present that data also here. So, but I'm not sure about the competition of MSW incineration with the another renewable energy sources. I don't think so, sir, because I don't have much idea about that one. So what is the competition and another technologies? So because basically I have been worked on the incineration plants, especially MSW incineration from South Korea. So that's why here I taken this project through DST Women Scientist Programs.
Okay. Maybe before you go for your second question, Saurabh, I have a question. Did you analyze the input to the plant? Because what you are saying that in the output you find more, construction demolition material there. Yeah? Always that's part. If I understood you correctly, as the contents in the bottom ash. However, did you analyze what was really going into the plant to result in this? Because ideally, construction demolition waste should not really be going to this plant. Or I understood it incorrectly.
What, ma'am? Can you please repeat it?
So the input to the incineration plant, the input material, did you analyze the input material to the plant?
Input materials, it's, ma'am, the size is very large, ma'am. Suppose completely it's after the incineration only we can analyze the samples, ma'am.
No,
Because
the composition of the not the chemical composition, but the
physical composition of
physical
waste, ma'am.
composition. What was
Yes,
exactly
yes.
going inside? Yeah.
Means during the incineration, what happened with
Before.
another material?
Before. Yeah. So what is the input material to the incineration process?
Oh, it's all kind of solid waste, ma'am, municipal solid waste. So it includes glass, papers, plastics, iron materials, ferrous, non-ferrous materials. It's all kinds of household waste through, wet waste also it's sometimes incinerated. So that is wet waste completely another leachate method following. But incineration, so all kind of household waste and another waste. So is it okay, ma'am?
Yeah, but you did analyze that is my question.
Yes, ma'am, I did because
Okay.
I will show you. Yes, definitely.
Yeah.
Because
That's
here
okay.
in Tirupati, we have only two recycling, not recycling, just segregation plants only, ma'am. Incineration plants, one is located in Guntur Jindal company, Andhra Pradesh, and another one is Ramki Group in Hyderabad, Telangana state, ma'am. So,
Okay. Sure.
yes,
Sure. That I understood. Yeah, I just probably that slide I missed.
yes,
Okay.
madam, I have, yes, ma'am, I did the composition.
Thank you.
Yes.
Saurabh, you had another question?
No, Vishalji, it was competition only that she highlighted. Okay, next concern is that we have 10 presentations in the session. Raktim, may I request you to please identify other presenters if they are here also?
Vaishali and Saurabh, can you hear me?
Yes, Dr. Ghosh.
Yeah.
I
Good
can hear
morning.
you.
Good morning. Yeah. So, Professor Marvat Elhos and Professor David, one from Nigeria and other from Lebanon, I asked them to make the presentation here because I could see that they are present, but somehow they were not, compatible. So in that case, both of them will make the presentation now. So you can comfortably call them for making a presentation and they will present it. And I'm checking others whether they are there or not, because sometimes you know that there is a problem in connectivity. So if it happens, so that's why at least speaker David from Nigeria and speaker Professor Marvat from Lebanon. You
Yes,
can
can you
call
hear me?
them.
Hello?
Yeah.
Can you hear?
Yes.
Yes?
Yes, Dr. Mevat.
Thank you. Because I couldn't
Yeah,
I
we
couldn't hear
request
you
you to
before. I
please
had a
start
problem with
presenting.
the speaker. Okay.
Thank you.
So now be comfortable to make a presentation. Chair will call in and he'll do that. Okay, thank you.
Dr. Mervat, you may please start presenting. I think Vishali is having some issues in joining.
So please, can I be the last one? Hello?
Yes. Dr. Mervat, are you trying to say?
Yeah. Can I present the last person? Am I the last person?
You are the last person, but if you want to present now, please, you can.
No, please, keep it to the last person.
Okay.
Do one thing. Now you have a presentation with Archana. Okay? So you are there in hall 2 from Nigeria. Write down in the chat box that you are here and to present. Then they will call you because chairman is asking but nobody is responding.
Do we also have Oluwade Joshua from Nigeria? Mr. Oluwade? Maybe then I'll request Dr. Mervat to please start presenting, as we should not wait any further till the others join. Raktim, can you please check who all presenters for the session are here? Raktim?
Archana Purohit, Mohini Chowdhury from Indore. Ms. Mohini, I think you are present here now.
Miss Archana Purohit and Mohini Jadon. Please confirm if they're present. Yeah, okay. May I request Ms. Mohini Jadon and Archana Purohit to please present their study of vehicle tracking and monitoring system in solid waste management in Indore city?
I request to please make the presentation. Please unmute and open the PPT and share the screen.
Hello, sir. Good morning. Mohini Jadon here.
Yeah.
Sir, actually, my topic is not on vehicle tracking system. Hello, sir. Can you hear me?
Yeah, you please make your presentation. Vehicle tracking. I think they have listed something. You please make your presentation.
Yes, sir. Just a minute, sir.
Sorry, I was having some technical problems. So who is presenting now?
Madam,
Hello,
Miss
ma'am.
Mohini Jadon is presenting.
Okay, thank you.
Okay. Ma'am, I'm not able to share my PPT actually. Just a minute.
Yeah, otherwise maybe Raktim, if you can help us with sharing this Yadav PPT from the Secretariat.
Ready.
I share you my mail ID. Please send your PPT in my mail, Ms. Javan.
Okay. Oh, yeah. Yeah, I'm just sending it.
Madam, please tell me after send that.
Sir, I'm just sending my mail. Just a minute.
Rectim, who will be there next after Miss Jadon?
Only one are there. One is there. Professor Marvel El Rose from Lebanon. Professor Marvel, please be ready. Okay. For finishing Ms. Jadan, we will make your presentation.
And I will suggest, Ms. Marvel, if you can also send your presentation to Raktim. Yeah. Raktim, if you can share your email ID already. Yeah.
Professor Marvel already shared the presentation.
Okay, then maybe we start with Professor Marvel and we come back to
That
Ms.
is okay.
Jadon. Yeah. Okay. Please go ahead, Professor Marvel. Marwat. Yeah. Okay. Professor Marwat, yeah, please go ahead with your presentation. You are not audible somehow.
Now, can you hear me now?
Yeah, we can hear you, but we cannot see the
Yes, because
presentation
I had a
anymore.
problem with the voice. Now I will do it again. Okay, don't worry.
Okay.
The most
Great,
important is to hear me.
NC as well.
Okay. Is it okay
Yeah.
now?
Yes, absolutely.
Okay. Good morning, good afternoon. Have a good day is the better things to say in this time, because everyone has a different time in his country. I'll present my project, which is talking about the circular economy of plastic packaging, current practices, and environmental impact of the polypropylene mechanical recycling plant in Lebanon. I'll give you some basic information about the plastic industry and the polymers, then we'll go into the impact assessment. So plastic production has increased markedly over the last 70 years and become an integral part of all our lives and play an irreplaceable role in our day-to-day. So we are using it every day. But we have to know that not all plastics are recyclable. We have only 4 types of plastic, which are polyethylene, polypropylene, polyestyrene, PET, and PVC, which are commonly recycled. In my project, we are going to recycle only PP, polypropylene. It is under the international code, which has number 5. This is the shape of it.
Excuse me.
And its general properties are excellent chemical resistance, high melting point, hard, flexible, translucent, strong, lightweight, and has many good properties.
Then your slide is not visible here.
Miss Marvat, your presentation is not visible. So we
Not?
have marked. No.
No. Okay now?
Yeah, we can see you now.
Can you see me? So shall I continue or repeat?
No, just show the presentation from wherever you are. If you
Okay.
could just share your desktop
Okay.
or share the presentation.
Can you
should
see
be
it now? Better?
Not yet. Not yet. Maybe you close the camera and then your bandwidth will be
Just
better.
share your screen, madam. Just share your screen.
What to do? What to do? What shall I do? Stop video or?
No, not stop. Yeah, stop video and then next to it there is a share screen. Share icon.
I did share.
Yes.
Is it okay now?
Yes, perfect. Yeah, please go on.
Okay, great. So, as I mentioned before, the project will concentrate on polypropylene, which is light, cheap, and has many good properties. And it is commonly used in many stuff. The most important of them for this project is crates, which are the containers, the plastic containers, okay, which are used in food processing and in agricultural area to store the fruits and foods into them. So the objective of my study is to do an environmental impact assessment for the construction and operation of mechanical polypropylene plastic recycling factory to recycle the local agricultural waste, specifically the krat that comes from local consumer, plus the plastic pellets locally or from abroad if we couldn't find them locally. Why we are doing that? Because nowadays the circular economy is a hot topic, and climate change, global warming, and the environmental effects of human being activities are destroying the environment. So we have to achieve recycling, reuse these materials for sustainability purposes, and through plastic packaging to avoid also production and ensure the environmental concerns are incorporated into all development activities without harming the environment. Plastic disposal options, we have 3 different options. We have recycling, waste to energy, landfilling. The current situation in Lebanon is landfilling for almost 80% of the municipal solid waste. We don't have any treatment for the industrial, electronic, or medical waste. So all of them are going into landfills or open dumps in rural areas. So also why we don't use the waste to energy, because as you know, the waste to energy incineration are expensive, and they are even that they are not available in Lebanon. And we have many plants in Europe, Japan, US, and in Asia, in developed countries, but we don't have waste to energy in Lebanon. So the cheapest and the quickest one is to go into recycling, which is efficient with low carbon presence, and reduce reliance on virgin materials, since we know that the origin of polypropylene and the plastic, reusable plastic, are fuel and oil. So normally what we have in Lebanon, we have a linear economic model, which is resource extraction comes from fuel, then production, distribution, consumption, then to waste, which is to landfill. Meanwhile, when we are doing circular economy, so after design and manufacturing, it goes to consumptions and use. Then from the consumptions, it goes into recycling plant, and then again into the market. So circular economy has many advantages over the linear economy. At least it reduces the plastic waste and pollution through product design, keep resources and product in use, regenerate the natural and preserve the natural system. Don't go to the nature to take virgin plastic or virgin oil. Separating plastic from fossil fuels versus renewable feedstocks, thus reducing communities' dependence on depleted reserve, since we don't have too much fuel in the world in the coming decades. Recover material value from waste to prevent material removal and reduce cycle losses. Circular economy has all of these advantages, so we go into circular economy with recycling. So method of reprocessing. In mechanical reprocessing, we have the primary. In recycling, we have primary, secondary, tertiary, and quarterly. So we are doing in this project mechanical reprocessing, since the purpose is to process post-consumer plastic and recover secondary raw materials for the production of the new items. In addition, if we do mechanical recycling, it needs separation, washing, and preparation of plastic waste. All of these are essentials in the industry. Methodology based, our methodology is based on the Lebanese guidelines for environmental impact assessment, and this project fall under the category B, which needs general information about the project, policy, and legislation, description of the environment, description of the plastic process, identification of the environmental impacts, and at the end, we have to cover an environmental management plan. So general information about the project. This is the factory that will be established in the Bekaa region. Municipal solid waste in Lebanon represent, as I mentioned before, 18% of the waste stream. The compositions of the plastic is 13% of the stream, and PP represents 16% of these 13%. Landfilling and dumping, as I mentioned, is the method used in Lebanon, and the problem of disposal in Lebanon is huge, because Lebanon is very small and the landfill needs big areas. Policy, as I mentioned before, I'm not going to talk about all the laws and legislations in Lebanon, but I would stress on that the project is a small industry fall under the category B, which is only an initial environmental examination required. Also, as I mentioned, it is in the Bekaa region. It's an agricultural area. As you can see, the site is bushland. It's far from the residential area, and this village has only 4,000 people. So it's far from. It's very good to construct a plant over there. Mechanical recycling. So the factory is small, 525 square kilometer. It's a hangar with parking for 4 cars. The equipments that they have: extrusion, chiller, and compressor. The main power, it needs 8 persons to run this project. or this industry. So this is the injecting molding process, this is the crusher, this is the chiller, and this is the type of grat that it will be produced. Of course, the industry or the factory will produce different size of grats. It depends on the consumer what they need. The plastic recycling process, post-consumer, going to shredding, from shredding to cleaning. As I mentioned before, we need the cleaning. And if we need the addition, if the quantity of the recycled material or the waste that come to the industry is less, so we add some pellets with the raw materials. We mix them, and then goes to extrusion injection, and the leftover or the residue from this treatment goes back to recycling, where no plastic will go to landfill. So, and then we have the production of grats. The size, as I mentioned, it can be half 50, 50, 50, and half 50 centimeters in each height, depth, width, and the weight is half kilogram. And many different shapes can be done at the same time. Depending, very, very important things, that it is depending on the quantity and the quality. So we cannot use or we cannot recycle any kind of any type or any kind of waste. The quantity and quality is very important for this kind of grats. That's why pellets are used and are added in case we don't have enough pellets. No additive will be used during process, and the water used in the system will be recycled. That's means we don't have a problem of water. Factory will produce approximately 1,500 grats per day, and this technology of manufacturing containers is new to Lebanon. We don't have it in Lebanon, as I mentioned. Maybe, probably, or some of you know that the political situation, social, financial, economic situation in Lebanon now is in crisis. So we don't have such technology, and since the cost of this treatment of this plant is only 350,000, it is applicable. It's we can manage with private sector to do that industry. Meanwhile, at the same time, it has been successfully implemented in numerous countries in the world. Identifications of the assessment, that means now we will go into the impact assessment of the project. So we evaluate the project under negative minimal impact, no impact, or positive impact. According to the construction phase, so the construction phase, we implement air, water, solid waste, and socio-economy, and based on the environmental impact that is applicable in the country. So we have environmental impact from cleaning and grading, preparatory work of the project, foundation work, mechanical equipment, and material and equipment transportations. All of these bring some environmental impact, such as dust, soil, noise, visual impact, and sometimes wastewater generation out of that. Summary of the qualitative impact during construction: air pollution, of course, we have minimum, noise, traffic, hydrogen, and water quality. There is no impact on it in that area. Wastewater effluent, a bit. Flora and fauna, we took them into consideration, so no minor impacts. Socioeconomic, it has a positive impact, and cultural and social infrastructure also, it has a positive impact. So these are the main impacts during the construction. During operations, we go into air emission, traffic, noise, and the same as the one into construction. But here we have to add the solid waste, biological, and public health and machinery, because we have some people working in the industry. So public health is very important indoor or in the industry. So as the impact, air emission is minor, traffic minor, noise minor, solid waste minor, biological environment we have positive because it is a bushland, and in this industry we will plant some trees around in the factory surrounding the working hall. Visual minor, socio-economic positive because the industry will employ some people. Public health minor because we have to have good management and safety into the system to make the industry very well. So major sources of air pollution are plastic granules, warning, melting, gases from different machines coming from projects vendor, or stack and emitted into atmosphere. As you can see, I show you the location. It's very far from the residential area. So I'm not going into the details in talk about. I'll go to environmental management plan, where mitigation measures was done for the machinery, for public health, for air quality, noise, traffic. So we, for example, for noise, the proponent should take into consideration that there should be silences within the factory, and the regulation of regulating the accuracy of the machines, isolate the machines such as air pressure machine, and any other acoustic needed for in the design of the system. Solid waste management arrangement, all products. We don't have waste coming from the recycling, but we will have some municipal waste coming from the people who are working over there, and these are minors. So we made some mitigation through separation solid waste to types, recycle faulty products which are in the industry, trimming and polypropylene packaging plastic. Wastewater, we will have regular inspections, and monitoring will be all around the hour based on the Lebanese regulations, and heat flow increase, so air conditioning will be installed, and good ventilation will be also installed in the factory. So mitigation measures, what locations to implement, all of them will be taken into consideration. Conclusion, as you can see, plastic recycling process is the best way to economically reduce the use of virgin materials, construction of polypropylene recycling factory. So part of a huge solid waste production, but this system is affordable to be installed and established in Lebanon. In a way, we can save the environment. Mechanical recycle encompasses lowest input of energy. So we since it is reusable, recyclable, so no high energy is needed as when you are producing the virgin plastic. From practical application of bond, byproducts should be similar properties of commercial grade plastic with respect to type and monomer origin. So since this factory will recycle only monomer, which is the polypropylene, no other plastic polymer will be used or will be recycled in this industry. So no adverse negative impact are envisaged, and potential minor impact are manageable through proper policy and good supervision practices. In Lebanon, as in all countries, after the construction and the operation of any factory, they will have auditing, where an independent consultancy will come and check and monitor and evaluate the process and the procedures and the management of the factories, so everything will be under control. Environmental benefits, so to achieve that, so we require the government policies could play a key role in managing and maintaining this network. As I mentioned, through the auditing, the yearly auditing, this factory need yearly auditing, not every 6 months. Government will enact more regulations and encourage recycling, enough for landfilling, enough for open dump. Everywhere, many people went to the moon and they didn't satisfied going to the moon. They went to another planet. We are in Lebanon still using the landfill and still using the open dump. This is a shame for my country, sorry to say that. Polypropylene recycling factory is feasible, sustainable options from engineering, environmental, and socio-economic points of view. So, and also it's the best way to reduce polypropylene waste. As I mentioned, no adverse negative impact are envisaged, and you know, this is repeated, sorry.
Thank you.
Yeah.
Thank you.
Thank you so much.
Now I request.
I can't hear you.
Yeah. Now I request Professor David Olukani.
So, shall I take my presentation?
Yes, thank you so much, Professor Marwat. And
Professor David Olukani.
yeah.
I request Professor David Olukani to please make your presentation.
Okay. We can see his presentation now. Great.
Thank you very much, Prof. Yeah, I say good morning to us all from here in Nigeria. And we are happy to make this presentation here. Actually, it was scheduled for yesterday, but for one reason or the other, we are making it today. And I want to appreciate the organizers of this conference, particularly Professor Ghosh, whom has really given a lot to making this conference come to reality. So we pray for more grace and strength, coupled with wisdom, even to get the best out of the conference. So the title of this presentation is Biogas Recovery from Anaerobic Digestion of Palm Oil Processing Sludge in Nigeria. The next slide, please. Our presentation outline is as shown on the screen. I have the introduction, I have the problem statement, the research aim, the research objectives, we have the literature review, we have the methodologies, we have the results, conclusion, and the selected references. Next slide, please. The next slide, yeah. Oil palm is a beneficial, versatile, and multi-dimensional perennial fruit crop. 940,000 metric tons of oil palm is produced in Nigeria annually, which contributes to 1.5% of the global output. And you can see on the screen there, the oil palm, what it looks like. The next slide, please. On this chart, we'll see the countries that actually produces oil palm. That is the top oil palm producing nations. You can see Indonesia, Malaysia, Thailand, Colombia, Nigeria. I can see with an arrow shot there, 0.94 million tons. You can see Ecuador, Guatemala, Papua New Guinea. The next slide. So you can please press here, very good. So waste from oil processing palm oil bond, you will see that we have about 5 of different products that comes from, you know, this processing of oil palm. The first one is the empty fruit bunches, which is a kind of biomass formed during the production process of palm oil. The second product we'll see here is palm oil meal effluents called pomain, with high strength wastewater derived from processing of palm fruits. And also we have the palm kernel shell, which also are the shell's fractions left after the nut has been removed after crushing the palm oil. On the fourth part, we have the palm oil processing sludge called POPS, which is partly solid and partly liquid and have no practical use for palm oil millers. And the fifth one is a palm kernel cake, which is a feed byproduct that is used by the livestock industries. The next slide, please. So, what is biogas and why are we interested in deriving biogas from palm oil processing? You will agree with me that resource recovery is the order of the day, and any environmentalist will look at how can we get resource even from waste that are being generated. So one of the key products we want to derive from this palm oil is what we call biogas. So by way of definition, we see biogas is a renewable energy source that is produced by the biological degradation of organic matters in the absence of oxygen. It is a cheap form of renewable energy that can meet to a large extent the energy demands of the rural populace. So major gas produced is methane. In this study, we have used what we call anaerobic digestion system, which involves 4 stages. Step 1 is hydrolysis, step 2 is acidogenesis, step 3 is acetogenesis, and step 4 is the metagenesis. And there is something that happens in each of these 4 stages of producing the biogas. Please, the next slide. So what is the problem statement? During palm oil processing, approximately 9 to 30% of the fresh palm bunch becomes palm oil, leaving the remaining 70 to 90% as waste products. And for any environmental engineer or environmentalist, you think of what can you do with these waste products. The second question is that the palm oil processing sludge are usually left by the millers to decompose at the palm mill and plantation, since they are moist, heavy, and voluminous, which are undesirable features for transportation and processing. So with projected rise in palm oil production, it is also anticipated that waste production will continue to increase. As a result, steps to manage the waste produced by the process must be investigated to ensure effective environmental operations within the processing mills. And these actually are the problem statements why the research was conducted. The next slide, please. So the aim of this study is to design, 1, build, 2, and evaluate a biogas system with palm oil processing sludge as the primary substrate. Remember, I said we are dealing with anaerobic digestion for the production of our biogas. The next slide, please. The next slide, please. So this is a process, and our objective are 1, to design a biogas system that is simple to use, deploy, and maintain. The second one is to determine the pH and temperature of the slurry inside the digester daily using an HANA multimeter. And third is to estimate biogas yield from the palm oil processing sludge biogas system. The next slide, please. From literature, we have seen some persons who have actually worked on similar projects, but they have gaps. If you look at Sompong et al. In 2012, the gap that was there was that the thermophilic anaerobic digestion is energy intensive and also very costly. Fast forward to 2019, the solid state anaerobic digesters are more costly to build. The use of substrate to inoculum ratio 3:1 is also uneconomical. This gives us a thinking line to know that what would be the best approach actually to deal with that. Looking at 2020, Kulichkova et al. Also talked about empty palm oil fruit bunches were not reviewed. So these are some of the things we looked at to say, okay, what should we do for that to improve upon the knowledge that is existing already? Now let's look at the next slide, please. It is important to note that there are also agricultural-based products that we can also derive, biogas from. Example is lime waste. We have done a project related to that. Yam peel is also an organic product as well. Rice husk is another project. Maize, cocoa pod residue, and plantain peel. These can all be found in literature of several derivable, products that could be used, for gas generation. The next slide, please. So just to quickly show to us a few materials in terms of when we have done the design and the construction. So in the process of the construction, we have the feedstock, the 100-liter reactor, the gas hose, clips, the pressure gauge, brass fitting, plastic fittings. All of this were bought from the commercial markets very close to the institution, and they were readily, available in terms of getting all of those to set up the system. The next slide, please. And this is just a simple schematic diagram of the 100-liter biodigester. You can see from number 1 to 10, all of these are labeled. From point 1, you see the bioreactor tank, the liquid valve, the slurry water outlet, the plastic back nut, the bioreactor lid, up to 10, which is the pressure relief system, just to make sure that we are able to get the gas at the appropriate pressure. The next slide, please. And this is the process flow within the reactor. You will see our mix ratio 9 to 0.9 to 8. That is the palm oil processing sludge together with the cow dung. The cow dung here acts actually as the inoculum that helps the bacteria within the system to come up and actually react or act, on the sludge. And we have the water as well. So 4.45 kg of the POPs was used. 4.5 kg of the cow dung, which serves as inoculum, was also put together with 40 kg of water. And this is the anaerobic digester, that is the reaction going on there. And we have 7.2 kg of the volatile solids, producing 3.51 meter cube of biogas. And you can see the wastewater generated 76 kg of wastewater and 1.8 kg of compost, which this compost also can be used, for manure that we enrich, the soil nutrients, which also have impact on the plants that will be grown on the soil. And this was done within a retention time of 30 days. The next slide, please. So these are the operation parameters for anyone who perhaps might much more be interested in seeing how all of this was done. You can see the organic load as I've shown us in the previous slide. The total solids 20%, the volatile solids. The feeding mode actually is a batch system, and the loading rate is a monthly thing. Number of the stages is just one. The inoculum that we have used is the cow, and the hydraulic retention time is for 30 days. And the starting temperature 35 degrees Celsius, the starting pH 5.2, and all other details that we have on the screen. Next slide, please. So this is the volume of the gas that was produced, and you will see on the 6 days was actually the days by which the gas was produced. We have that on the 8th day, the 15th day, the 21st day, the 25th day, 28th day, and 30th day. One may ask the question, why do we have these days? The answer straight to it is that since it's a batch system, also we try to agitate, the reactor in terms of a mechanical agitation for the biogas to be produced, and also for the products within the digester to actually mix through. And the total volume of biogas that was produced was 69.6 liters. And the number of tire tubes are also shown on the left, the vertical axis. The next slide, please. This is the slurry pH, because this was also measured as part of our objectives, if you can recollect. Average pH of the slurry is 4.7. The pH range is from 4.5 to 5.2, and it was extremely acidic slurry that affected biogas production. Let's move to the next slide. And also, this is the temperature variation, as we see here. You can see the slurry temperature and the ambient temperature. Not too far away, So the slurry temperature range was from 26.7 to 32.3, while the ambient temperature was also close to that. So the slurry temperature is dependent actually on the ambient temperature. And you will agree with me also that we operated within a mesophilic temperature range. The next slide, please. This is the total and volatile solids, that is before the digestion and after the digestion. You can see for the total solids, 85.5, and after 78, 60.5 volatile solid, and 54 after that. And for the organic content in the slurry, from 51.7 to 42. So the total volatile solids percentage decreased by 10.7%, while the total solids percentage decreased 8.7%. That tells us that within the digest there's a reaction going on, and naturally you will see, the total solids, decreasing over time. The next slide, please. So in conclusion, just to make it very brief for time's sake, successful design and build of an anaerobic digester system for treatment of palm oil processing sludge, cumulative volume of 69.6 liters of biogas was produced, which is a very great success. The low moisture content of the substrate in the digester tank was a key contributor towards the low biogas production. Proper and adequate installation of the anaerobic digestion system to control temperature fluctuation will be a contributor towards improved biogas production if the moisture content of the substrate was optimal. It's important to note here that this is a project in a phase, and we have commenced this, and it's a work also in progress because other things have been realized that we also need to incorporate. However, we understand the placement of the fact that we need to get it, started. Then low pH control is the cause for low methane production in the biogas system. The next slide, please. So what are the recommendations based on the conclusion that was iterated? Further research should be conducted on better and improved means of temperature control of the anaerobic digestion system. External alkaline or chemically prepared buffer solution should be added to the substrate mixture to neutralize the pH drop in the acidogenesis stage, and the impact on biogas production should be monitored carefully. So when the experiment is being conducted for further research, sufficient water should be added to the substrate mixture to cater for the moisture content so that it will ensure improved production of biogas. These are some of the things we eventually realized at the final stage of this first stage of the research. Then further research should be carried out on efficient and safe methods of agitation to ensure homogeneity in the mixture as well as contributing to the overall moisture content. And the final slide. The next slide, please. So we all agree with me that our goal is to contribute also to the SDGs, which for this project, we have looked at goal 7 and goal 13. For goal 7 is talking about affordable and clean energy, that is universal access to modern energy, and also to increase global percentage of renewable energy. And goal 13 talking about climate action, which is actually reduction of greenhouse gas emissions and reduction of deforestation activities. So if we are able to get this biogas on cost, you will agree with me that instead of persons maybe using firewood, able to cook anything or to do anything within the factory where which all palm are produced, the biogas can be like it's just working in the interest of circular economy to see within that processing of the palm oil, persons can use the gas that has been produced. So that gives the system up and running and make it very sustainable. And also for the clean energy, you will agree with me also that biogas is a clean energy. And finally, the selected references that we are taking, and you will agree with me that we have made some contribution as far as this course is concerned. I really want to appreciate you so much for listening. Namaste. Thank you.
Thank you so much, Dr. Olukani, for the very nice presentation and the new system that you are talking about for palm oil biogas production. For questions, I think we will still wait on. Over to you, Raktim, then for the next presenter.
Yeah,
please.
then last presentation is Mohini Jadhav. Miss Mohini, can you hear me? Miss Mohini.
Yeah, we can see the presentation, but we can't hear.
Yeah, because the presentation is sharing from our side. That's why you see the presentation. But Miss Mohini, please.
Hello, good morning, everyone. Mohini Jadon here. Today, I would like to present on sustainable solid waste management and integrated approach of Indore city. So, next. Hello. Hello.
Yeah.
Yeah, you are audible, Mohini. Yeah, go on.
Hello. Good morning, everyone.
Yeah, we
Today
can
I am
hear you,
presenting.
Mohini, please.
Okay, thank you, ma'am. Solid waste management is a worldwide phenomena where improper, just a minute, sorry, where improper management of solid waste causes numerous hazards to living beings, environment, and also affects the wealth and health of Mother Earth. Solid waste management constitutes a serious problem in many countries of the world. Most cities, towns, and small towns do not collect the totality of waste generated, and only a fraction receive proper disposal. It is estimated that in a year, the planet produces 2.01 billion tons of urban solid waste, with at least 33% of it, to put it conservatively, not being handled in an environmentally sound manner. The average amount of waste produced per individual per head is 0.7 kilograms, but it varies greatly, ranging from 0.11 to 4.45 kilograms. While having just 16% of the world's population, high-income industries produce about 34% of the world's waste, or 683 million tons. I would like to define solid waste management. SWM helps to promote sustainable growth and a better standard of living by reducing or eliminating negative effects on the atmosphere and public well-being. In order to successfully manage waste for a municipality, a variety of processes are needed. Monitoring, collection, transportation, sorting, recycling, and disposals are also some examples of these services. Now, I would like to tell about my study area. Next slide, please. I would like to tell in India, I have taken Madhya Pradesh, and in Madhya Pradesh, I have taken Indore district, in which Indore city is my study area. As everyone knows that from last five times consecutively in Swachh Sarvekshan, Indore is being the cleanest city of India. So I would like to tell how how Indore is managing its waste in a sustainable manner. So the objectives of my study is to present status of solid waste generation and collection in the study area. Next slide, please. To study sustainable practices of waste management in the study area. Now the methodology that I've used is based on a pilot survey. Actually, I just surveyed my area. I just made a questionnaire of some questions and I visited my area. The data is collected by both primary and secondary sources. Primary data is collected by observation method, schedule, interview, and group discussion methods. Also, secondary data is collected from Indore Municipal Corporation, IDA, Pollution Control Board, GTS, garbage transfer stations, waste treatment plants, and other private organizations, NGOs, which are contributing for waste management. Now the types, next slide please. Now the types of waste and the methods which are used to dispose. As everyone knows that Indore is well known for its waste segregation, and at source Indore is segregating its waste in 6 categories. So I would like to just tell some of them, which is dry waste, wet waste, biomedical waste, hazardous waste, COVID-19 pandemic waste. Now, the method used to dispose of dry waste or to manage dry waste is material recovery center and recycling industries. The wet waste is managed by bioremediation method and turning process. The biomedical waste is incinerated and landfilled. Even the hazardous waste and COVID-19 waste. As everyone knows that COVID-19 it was a pandemic year from 2019, which was very, I must say, hazardous and very infectious to everyone. So it was so difficult to manage that waste. But that also Indore city has managed in a very well manner. And the waste is being incinerated, and the ashes which are remained are been sent to landfill sites. Next slide, please. Here I have shown the picture of the vehicle which collects the waste, and I have put it here because I would like to show that how Indore is collecting the segregated waste in 5 categories. The green one, which everyone is able to see, is for wet waste. The blue one is for dry waste. The black tipper at backside is for hazardous, domestic hazardous waste. The yellow tipper is for pandemic waste, and the blue one is for e-waste. Next slide, please. Now, the composition of municipal solid waste in Indore city. Here, I would like to tell that how this waste is composed. So, I would like to tell that the 41% of the waste is wet waste of the total waste generated, as the wet waste is somehow heavy in weight and is actually generated a lot in area, but it is managed in a very sustainable manner in the study area. Then we can say is metal, ceramics, plastic and rubbers, textiles and papers. All this waste material which is generated in the study area is actually managed in a very well sustainable manner. The waste which is produced in the study area is 1150 metric tons per day, in which dry waste is 550 metric tons and wet waste is 600 metric tons. The Indore city is divided into 85 wards according to its population, and for collecting the waste and all, it is being clubbed into 19 zones where the waste is transported, and then it is went finally to the plant that is situated on the outskirt of the city, which is named as Devguradia. Now the waste is managed in following processes, which is first of all segregation of waste. That at source waste is segregated into different parts, and then a vehicle comes time to time every day to collect door-to-door collect waste. After that, the waste is transferred to GTSs, that is garbage transfer stations, where that waste is compressed and it is loaded into big hooks, big hook loaders, or I must say big trucks, where this waste is transferred, and then it is transferred to Devguradia or the disposal plant. After that, we are trying to create some energy from the waste. That is the dry waste is being sent to industries for recycling, and the wet waste is used to produce gas, methane gas, which is used as in fuel in the city buses of Indore city, and the compost which is got in the process is used by the gardens and the agricultural farmers for as in I must say compost to those peoples. Please the next slide. Here I would like to tell of how the population trend has increased, and with that population trend, the waste is also increased in the study area. I would like to tell that in the year 2001, the population was about 10 lakhs and the waste generated in metric tons was about 600 metric tons. Slowly, the population increased, and I have put it here the data from 2011. Then it was 21 lakhs, where the I must say waste was 800 metric tons. In 2015 to 25 lakhs was the population, and the waste also increased. So this is the trend that I've shown here through a graph and a tabular interpretation I've done. And in 2021, where the population is about 31 lakhs of the city area, the total waste generated is 1150 metric tons. As in festive seasons, the waste increased to 13 to 1400 metric tons. But it doesn't make any difference because the waste is actually managed in a very sustainable manner way, and the waste is collected every day to day the waste is collected, so it is not a big I must say problem in the study area. Next slide please. Now I would like to tell about my discussions and analysis. So the waste generation and segregation. In Indore, the waste is produced in a segregated structure. The waste generators are divided into three categories: household, semi-bulk, and bulk generators. Local generators who produce less than 25 kg of waste per day are known as household generators. Semi-bulk generators have been arranged for uh, have been in categories of 25 to 100 kgs of waste that they produce per day comes under semi-bulk generators, and the bulk generators are the waste generators that produces more than 50 kgs of waste. In industrial and commercial areas, the waste generated in per day is 10 kg. If more than 10 kg waste is generated in a day, then it is just then it just comes into bulk generators, and they have to manage their waste at source, or they have to pay some high amount to the IMC to manage their waste, to collect their waste per day. Now I would like to tell that the domestic generators produce their waste in 4 separate structures, that is wet, dry, biomedical, and domestic hazardous waste. In biomedical waste, diapers, sanitary pads, PP kits, masks, and hand gloves are covered. The waste is by bulk generators. The waste is separated in 2 categories, that is wet waste and dry waste. After that, I comes to waste collection and transportation. The waste that is generated and segregated is collected door to door from each and every household of the town. There are about 650 vehicles working in a day, collecting the waste from households, about 100 vehicles who collect waste from semi-bulk and bulk generators. The tipper is partitioned into some types where the waste depends the categories of the waste that is generated the most. So in households it goes to 50 to 50 ratio, in commercial areas it goes to 60 to 40 ratio, and in industrial areas it goes to 85 to 15 proportion, or the bulk whole truck goes to in industrial areas. These vehicles collect both wet and dry waste in separate chambers. Domestic hazardous waste and biomedical waste is collected in a separate container attached to the back of the tipper that I have shown in the picture earlier. Please, next slide. After the waste is being collected, it is weighted. The weighbridge facility processing plant is an automated facility that serves as the primary point of contact for all vehicles seeking to offload their waste. After entering the plant, offloading the waste, all approaching vehicles are squandered to determine the waste that was brought by them. A receipt is printed and filled at the office at that point. This receipt shows the amount of waste moved, the type of waste which is being collected, the vehicle's enlistment number, the source transfer stations, and the vehicle's in-out time. Waste processing: dry waste from both exchange stations and bulk collection vehicles is offloaded at MRF locations, where it is further separated and prepared. The wet waste from the exchange stations and the bulk collection framework is trucked to the central composting plant for processing. Individual generators process the wet waste from the bulk generators on site. Residential hazardous waste is treated in a separate facility and transported in biomedical vans directly from the exchange stations. At the central biomedical treatment facility, hazardous waste is burned. Here I have put some pictures. The first picture is from GTS, where the waste is being transferred to hook loaders. Then the waste is compressed and filled into the big capsule in the last picture, where the waste is being dumped into the Devguradia, that is the disposal plant. And here is the last picture where I've put it of MRF, that is the waste is being uploaded by the JCBs, and through separators that is being separated into 11 different categories, and then this waste is being sent after separation of this waste or segregation of this waste, it is sent to recycling industries, which is somehow a source of earning or waste to energy, that I could say. Next slide, please. In dry waste, in an automated material recovery facility, dry waste, which accounts for around half of all waste, is sorted. Separation and sorting of waste materials as well as preparation of these materials for reuse or reprocessing are all done at the MRF plant. In the waste disposal process, recycling is critical. IMC has previously built material recovery facility center at Devguradia Trenching Point ground to manage and process such large quantities of dry waste. Pre-sorting is performed by 100 mm using a trommel system at this material recovery plant. The waste that passes through is classified as an inert material which cannot be recycled and must be disposed in a landfill site. Now it comes to wet waste. The separated wet waste is offloaded directly onto the compost plant in windrows by hook loaders from GTS or bulk collection vehicles. It is assumed that the waste will be fitted into one windrow one day. The waste leachate is stored into two leachate storage ponds that are connected to the windrows. The wet waste that is offloaded is then processed according to normal procedure. As a result, the city's centralized processing plant process and dispose 600 metric tons of organic waste. The wet waste in the area is also processed in a decentralized manner. The decentralized wet waste is processed at Rajkumar Milk Vegetable Market, Khazrana Ganesh Mandir, Chaitram Market, where it uses aerobic pit composting method and the organic waste converter system to convert flower waste into compost. Now the next process is biomethanation process, on which Indore is going to work on a large scale. At present, it has been on a very small scale. I must say it was a yes.
Mohini, please don't read the each and every line. It would be good if you can hurry up the presentation. Yeah.
Okay, yes, ma'am. Ma'am, I would like to tell about the biomethanization process, which is being used at in Indore at present. Only the plant capacities of only 20 tons per day, where the vegetables from the market which is being rejected are went there, and there through the process the methane gas is generated, and the remaining leachate or the compost is being used there, so they just don't generate any waste, and this plant is going to come on a very large scale. Now I would like to tell about the implementation of 3R model, where we are actually trying to reduce, reuse, and recycle our waste. So waste reduction is the primary target which the IMC has used. The reusing, that is the waste which is the material which is not in use to us is given to some other peoples. Here are some days which are decided to collect the waste which can be reused by other people, and recycling. So paper and all are the recycling. I must say recycling here, glasses and plastics, all those things. Now I would like to come on zero waste model. Please, next slide, please. Here I have shown that Indore is the first city who is working on zero waste model. Actually, here are some wards which are now comes under zero waste area. About 6 wards here are categorized for zero waste model, and they have won even some prize money also, which was kept by IMC. The most preferred thing is here is at source reduction and reusing. After that, we comes for recycling. composting, waste to energy, and the least preferred model.
Miss Mohini, you
that
have one
is-
more minute to finish your presentation.
Okay, ma'am. Okay, ma'am. Which is the least preferred model here is the landfill size. Now I would like to conclude my study. Here, in the arts, it is promoting the 3R concept, where reduction of waste is very important, and recycling of waste, which helps to minimize the greenhouse gases, the virgin materials which could be used and recycled by some other people or industries, and at last the composting organic waste, which is used for agriculture or for gardens and all. So biomedical waste is also somehow handled in a very great method, and the gas which is released is used by the hotels or the buses in the study area as a fuel. At last, the next slide, I would like to say thank you to everyone.
Thank you so much, Mohini. So
Thank you.
we have one last presenter who somehow did not come when we were
Mr.
calling.
Oluwadare Joshua,
Yes, exactly.
yes, please make your
Question.
presentation.
Okay.
Sorry, we are really running a little late.
Sir, please finish your presentation by 10 minutes, okay? Because our next session is special session 4 in this hall from 12:30 p.m. IST.
So Joshua, if you can put your presentation on full screen, it will be really good.
Hello?
Yes, we can hear you.
You can hear me? Okay, fine. Can you see my screen?
Yes, we can see your screen also. If you can just put it on full screen, then you are good to go.
Okay, thank you very much.
Please.
Thank you very much. So, as has been introduced, my name is Oluwadare Joshua Oyebode from Civil Engineering Department, Afebola University, Ado Ekiti, Ekiti State, Nigeria. My topic is assessment of current status of waste management in Nigeria, best practices and implementation strategies. So my outline will take this way. There are unresolved issues on waste management, resource efficiency, and recycling systems in Nigeria. This study assesses the current status, implications of dangers, and hazard posed by messy disposal of solid waste on Nigerian environment. Waste management situation in Nigeria currently requires concerted efforts to sensitize the general public on the need for proper disposal of solid waste. Waste generation in Nigeria is on the increase due to rise in population resulting from techno-economic development in cities and the pattern of production and consumption of materials. The global population and increased urbanization have resulted in the increased production of municipal solid waste, thus becoming a critical issue as a result of its poor management and inappropriate disposal. This is particularly the case of developing countries. The current waste management prices in the nation are fast becoming a national issue and unsustainable, leading to apparent environmental risk. And this risk has to be addressed. One of the challenges of Lagos State is efficient and cost-effective solid waste management. The implications, that is the environmental, economic, social, and financial for managing solid waste gives credence to the renewal campaign for resource conservation and environmental sustainability. Thus, the 4 Rs of waste management, that is reduction, reuse, recovery, and recycling, are being demonstrated through establishment of compost production plants, championing of waste to wet initiatives and renewable energy. This is done by one of our presenters today. This is one of the paper by Olukanya Onasanya 2018. We can see so many researchers are working on the waste management in the country. The level of healthcare waste management practice was found to be unsustainable in Nigeria due to limited resources. Measures to improve the healthcare waste management practices in the country need to be put in place. It has been recorded that Nigeria generates over 32 million tons of solid waste yearly, and only a fraction is collected. This is a lot of volume. In Africa, rapid urban growth has exerted massive pressure on cities, towns, and surrounding areas. Waste collection and disposal are the major problems faced in developing countries in solid waste management. Yet, it is one of the most difficult operational problems faced by most urban areas in Nigeria. So methodology used include the literature survey, checking of previous policies and issues linked with solid waste management with circular economy and resource efficiency in view. In Lagos, the main governmental agencies that have been entrusted with the responsibility of keeping the environment clean are the LOMA, like the Lagos State Waste Management Authority, LASEPA, the local government councils, and the Ministry of Environment and Physical Planning. Treatment of urban waste is achieved by mass burn, that is open incineration, which pollutes the environment. This is not hygienic enough. Incineration is not. Then this is an overview of food waste management in developing countries, where we have the current status and the future perspective. In looking at the current status, we look at the food waste generation, policy, regulations, and recycling treatment. And the future perspective include a case lesson learned, integration of federal waste management system design. And municipal solid waste management include many very different activities, which include disposal, energy recovery and recycling, reuse, minimization, prevention. And looking at this, the least preferred is the waste disposal, followed by waste recycle recovery, waste reuse, waste reduce, while the most preferred is the waste prevention. If it's possible, if we can achieve this will be better for our environment. And looking at the hierarchy for the household waste, follow the same pattern. If we can prevent, that's the best. And looking at the various recyclable waste, looking at paper, which are about 27%, glass 4.5%, plastic 12.8%. Plastic waste is a lot of waste which can affect our surface water, which can affect the aquatic life, which we have to look at. And we have a food waste, food about 14.6%. All these are lumped together. And when we look at traditional solid waste management strategy in Nigeria, we look at the waste generation and characterization. This has to be done well, and waste collection and transportation, and waste disposal and treatment is also germane. Best practices and implementation strategies is very, very important. It was discovered that population growth and change in government policies contribute to poor waste management, because an average Nigerian produces 0.43 kilogram of solid waste per head, that is per capita per day. Waste management practices differ from nation to nation, depending on the waste sources, types, and characteristics. It plays a vital role in nature's ability to sustain life within its capability. In many developing nations of the world, it has become a recurrent challenge, especially in urban areas. And we saw that Nigeria produces 0.43 kilogram. We've looked at this. Then it was concluded that solid waste management requires serious attention in rural areas and urban centers to avert environmental hazards and other impending challenges. A political, cultural, and socio-economic framework need to be checked and restructured. Proper records of finance, other activities should be kept for references and effective management strategies. Illegitimate levels should be reduced, and the government should intensify enlightenment campaign to produce more waste disposal containers, more toilets in homes and public places such as markets, schools, and government universities. Recommendations. Research and trainings on waste management should be funded at all levels. People should be enlightened on best practices, implementations, procedures, waste recycling, and conversion for further utilization in institutions industries, and residences. An integrative management system as a suitable model for management is suggested for most developing countries, including Nigeria. Based on this finding, a roadmap for the actualization of a sustainable integrated solid waste management strategies were recommended for adaptation and adoption by the Nigerian solid waste management authorities and agencies. Illiteracy levels should be reduced, and the government should intensify enlightenment campaign to provide more waste disposal containers, more toilets, and all that. Research and trainings on waste management should be funded. We have looked at this, and people should be enlightened. The general enlightenment will really help to, and with this, we can achieve best practices. These are part of my references. I am really grateful for the organizer of the conference, for the chairman of this section, for the opportunity given to me to present my papers in this 11th International Conference on Sustainable Waste Management and Circular Economy. So I'm very, very grateful. Thank you for listening. I welcome comments, questions, and contributions that can really improve this paper. Thank you very much. That's the end of my presentation. I'm very, very grateful. Thank you very much.
Thank you so much. Maybe we can take the presentations now.
Now request the chair and co-chair please conduct the Q&A session, question answer session.
Yeah. So maybe the first question to Mohini, how is it ensured that dry waste less than 100 mm size is inert? If there is any system for ensuring the same. This is for Indore.
Hello?
Yes. Thank you, Joshua. You can stop sharing the presentation and then we go into the question answer session. Thank you so much. Yeah. And the first question would be for Mohini, who was presenting the Mohini Ms. Jadon, who was presenting the case from Indore. How is it ensured that dry waste less than 100 mm size is inert? If there is any system for ensuring the same.
The legal frameworks that has been put in place need to be strengthened, and the solid waste management strategy has to be followed. And there are a lot of laws and policies, but the implementation is the major issues. So the implementation strategies has to be strengthened because the populations are growing, and we have about 0.3 kilograms solid waste per person per day. So this is a lot, and we need to work more on the literacy of our people, and the research and trainings must be funded at all levels. Thank you.
Thank you, Mr. Joshua. Okay, so there was a next question then regarding the hazardous or domestic waste management for and as well as COVID related. I think this is again for Indore.
Mohini.
Yes.
Yeah.
Yeah, I didn't get the question. Sorry. Yeah.
Joshua, the question is not for you. The question
Okay.
is for Mohini.
Thank you.
Yeah.
Thank you.
Thank you so much. It's for the city of Indore. However, he is not responding. Then maybe we move on. Saurabh, would you like to take the next question? Ask the next question. Yeah. Mohini, can you hear us?
Yes, ma'am.
Okay. So there was a question for you regarding any figures on biomedical hazardous or COVID waste generated in the city, and what is the system of storage and disposal for the hazardous waste?
Yes, ma'am.
Indore.
Ma'am,
Yeah.
actually, the biomedical waste in the study area per day it was generated about 120 tons in a day. when the second, I must say, when the second जो लहर आई थी, जो सेकेंड जो भी पीरियड आया था कोविड वेव में, at that time it was about 120 tons per day waste that was generated, and the waste that was generated was directly collected by the Hoshvin incineration plant. They just collected a plant. First of all, they were disinfecting the waste that was being generated through the whatever the liquid they were having. Sorry, I'm just forgetting that name. Sorry. And they just first disinfect the waste, and directly the waste was transferred to the incineration plant, and the waste was incinerated there.
Okay, so they were basically incinerating the biomedical and hazardous waste. Okay.
Yes, yes, ma'am.
Okay, thank you. That answers our question. Now this is from the presentation from Dr. Olukuni, Professor Olukuni. Are you there?
Professor David Olukani.
Okay, he does not seem to be. Okay. Then there was a question for the presenter from Ms. Triveni. Ms. Triveni, are you there? Yeah, but by the time she comes, Saurabh, I think you have a question?
Yeah, I think Ms. Triveni answered during mid of the session.
Okay.
I had a question that I can see also in the chat for Dr. Merwith, who was talking about the polypropylene recycling.
Yeah.
I have two questions from Dr. Manuja and from who?
Alok.
Hello. Yeah. So according to Dr. Manuja, in fact, this industry hasn't been operated yet. According to Lebanese law, the environmental impact assessment should be studied ahead, submitted to the Ministry of Environment and the Ministry of Industry for approval. Then, accordingly, when it is approved, the owner of the industry start doing the construction and operation. So concerning your question, the impact on machine life and maintenance like this, so I cannot study that because as a consultant, my role is to study the environmental impact assessment, not the machine life, you know. And this factory is still under construction and has not been operated yet. So I don't know the impact on machine. I'm not the owner of this, you know, so I cannot explain it. And according to, again, I agree with you, you know, everything related to economic. No answer. Probably the owner of the factory will not use the virgin material if he will find it is not feasible economically. And it is an option, probably he put it in the process because later on, and me as a consultant, I have to include that because when auditing will occur, they have to see the process and everything included in the study should be implemented. So if I don't include that pallets, virgin pallets will be introduced into the system, that means he is lying to he is doing something not available in the study. So for me, I included, as he mentioned, as he gave me the process, you know, the flow chart, and I did the things accordingly. Another question, I have it from Dr. Ranjan. So I will share the presentation. I will share the presentation. Sorry, you know, there is no cultural heritage in the study. I didn't study it, and I'll show you the study too. You know, this is the study. Table summary of during construction. I don't have heritage. I didn't include it. So by mistake, I don't know how I included, probably because I'm working on another EIA and I did the copy paste and because I was, you know, under hurry. So as you can see, I haven't included air pollution, noise, you know, traffic, transportation, water effluent, solid waste, flora and fauna, hydrology, water, health and safety, economic. I didn't mention the heritage, cultural heritage, so it was by mistake. Sorry for that. And thank you for telling me.
Yeah, thank you so much. I'm sure the discussions must have been fruitful. Request you to please stop sharing your screen, and we can just go on. I will now request Saurabh to just give us a summary of the day. And I would request all other people to please mute their mics. Whoever is entering, please mute your mics.
Am I audible?
Yes, please.
Sorry for the background noise. This session for today has been very fruitful with the solid waste management second session. If we look at the sessions that we had, they talked about the effect of solid waste management or urban flooding. We talked about that in Nigeria, as well as CO2 sequestration from municipal solid waste into this sector. We also looked at the plastics utilization, circular economy concepts for plastic packaging, in which we were talking about polypropylene basically getting mixed with the virgin plastics getting mixed with recycled one, and the environmental management plans followed with that. We also heard about the oil palm, that is a food crop in biogas. That was interesting as a co-digestion with cow dung to be utilized. And then it was interesting to look at the Indore solid waste management integrated approach. And lastly, we talked about the waste management in Nigeria, which talked about many issues, and there were many linkages when we talk about the global economy, waste trade, and global waste challenges that we see across. So that was a fruitful session. I thank our chair, Ms. Vaishali Nathan, and the session. Back to Vaishali ji. Thank you.
Yeah, thank you so much. I think it was a really fruitful session, and we look forward to more interesting deliberations in the near future. I hope the session was also useful for the presenters, and they got some useful feedback from us. Thank you so much.
I request all the delegates to please open your camera for photograph. Please open your camera for photograph, and also I request the chairs kindly send us the rating sheet and chair summary on the mail. Mail ID I have already provided in chat box. We now close the session. We request all the participants to please join the next session in Hall 2, that is special session 4 waste management towards a more resource efficient and circular economy in Vietnam. Timing 12:30 p.m. IST.
Thank you so much, Akhil, for your wonderful support. Thank you to you and your team.
Thank you.
Thank you, everyone.
Welcome, madam.
Thank you. Thank you very much for everyone, and I hope to see you in the coming conferences.